Welcome. Today we take few problems on probability. So our first problem is a pair of fair dice is thrown 3 times. The probability of getting a score of 9 twice is option 21 by 729, 11 by 729, 8 by 243, and 7 by 729. Acha, I'm repeating the problem. A pair of fair dice is thrown 3 times. Then the probability of getting a score of 9 twice. We have to get a total score of 9 twice. Its probability is that. Actually, 2 dice are taken and thrown together. Then our success is, if the sum of the score is 9, then this is our success, and otherwise it is failure. So let us see, when 2 dice are taken together and thrown, then how we get the total score 9. Let us see. Number 1, if 6 in first die and 3 in second die, then total score is 9. Next, 5 plus 4, this is also 9. 4 plus 5, this is also 9. They are not same. This is in first die 5, but here first die 4 and second die 5. And moreover, 3 plus 6. And you see, there are no other possibilities of getting a score of 9 from 2 dice. Okay, next, let us suppose A is the probability of getting a score of 9. Now let us see what is the probability of that. So this is one possible case, second, third, fourth. 4 possible cases are there. So probability of A that is getting a total score of 9, it is of the type m by n. Here m is equal to 4 and n is equal to 36, 6 square. Why 6 square? Now for 1 die it is 6. For 2 die it is 6 square. 3 die it is 6 cube. So it is 1 by 9. So probability of getting a score of 9 for 2 dice is 1 by 9. Now we have to find the probability that if the dice thrown, if 2 dice are thrown 3 times, then probability of getting a score of 9 is how much, and options are that. Now you see, we have taken that A is the total score 9 we have taken. If otherwise it is not our success, this is our success, either this or that. So A total score 9, its probability is 1 by 9. Suppose that A total score is 9, it is our success, otherwise it is our failure. So in the experiment we have actually two things may happen, either success, that is getting a score of 9, or another it is any other number other than 9. So probability of A is this, and probability of success is our 1 by 9. So otherwise it is failure. Probability of failure, it is 8 by 9, 1 minus that, say it is 8 by 9. Now it becomes a binomial distribution because either it will be sum will be 9 or not. So two events are there, and probability of success remains same throughout the trial. Probability of failure remains same throughout the trial. So it is a binomial distribution, and our problem is to find the probability that out of 3 trials, 2 will be successful. That is, 2 we get in 2 trials, sum of the phases is 9. So actually probability of 2 success is equal to n's formula is NC x p to the power x into q to the power n minus x. It is equal to n is your 3 out of 3 trials, 3C 2 success. Probability of success is 1 by 9 to the power 2 into probability of failure, this to the power n minus x means 1. So that it is equal to, this is nothing but 3 into 1 by 9 square into 8 by 9. So that they together is 3, 8 by 8, 81 into 3. So probability is that this is our correct option. Next problem. The next problem is the probability that a leap year contains 53 Sundays, leap year. Contains 53 Mondays. Well, once again I am repeating the problem. A leap year is chosen at random. What is the probability that in that leap year 53 Mondays are there? We know that any leap year contains 366 days. Let us see how many complete weeks are there. So that divided by 7. So we see that there are 52 complete weeks. So it means that 52 Mondays must be there and 2 more days. In these 2 more days, maybe 1 Monday or may not be 1 Monday. The distribution of these 2 days are as follows. This Sunday and Monday. They must be 2 consecutive days, these 2 excess days. Then Monday, Tuesday, Wednesday, Thursday, Friday and Saturday and Sunday. Next Sunday and Monday I have taken it into account. So actually any leap year must contain 366 days. It has 52 complete weeks. So it means it must have 52 Mondays, 52 Sundays, 52 Mondays and so on, and 2 more days. These 2 more days are can be distributed like that. Sunday and Monday, Monday and Tuesday, etc. So on. Now, our question is, what is the probability that a leap year will contain 53 Mondays? 52 Mondays is guaranteed. 52 weeks are there. And 2 excess days can be distributed like that. Sunday, Monday, and so on. Now, we see, in this case, one more Monday is there. In that case, one more Monday is there. No Monday, no Monday, and no Monday. So, out of these 2 days, there are possibilities that two days, two choices are there that it may be Monday. How many out of how many days? How many choices? Distribution is 1, 2, 3, 4, 5, 6, 7. Out of these 7 choices, there are 2 cases where one Monday is there. So our required probability is m by n is equal to 2. Monday and Monday, 2, and n total possibility is 7. So answer is 2 by 7. Oh, it is not yet given. That options are for the last problem, not this problem. So 2 by 7 is our correct answer. 2 by 7. So next problem. Next problem is, one coin is tossed 5 times. One coin is tossed 5 times, one after another. The probability of getting head for the second time in fourth trial is options. First I write the options. 3 by 8, 3 by 16, 5 by 16, and 7 by 16. Now let us see what is the problem once again. One coin is tossed 5 times, one after another. What is the probability that in its fourth trial, head will appear for second time? First trial, second trial, third trial, fourth trial, and fifth trial. 5 trials are there. In fourth trial, we must get a head. And this is for the second time. Heads for the second time in fourth trial. So before this trial, there must be one head. And in the fifth trial, it may be head or tail, because condition is that in fourth trial, one head will be there, and before that, one head must be there. That's a probability of head. Very clear that it is half, either head or tail, so it is half. And probability of tail, again half. Actually, we see that if head appears, then success. If tail appears, it is failure. So once again, it is a problem of binomial distribution. In fourth trial, there is a head. So in that case, one head is there. Before that, in first three trials, one head must be there, and it is a binomial distribution. So out of three trials, one success, that is half to the power 1, and two failure. Failure is again half. So it is 1 by half to the power 2. And this is fourth up to fourth trial. This is for three trials, first three trials, fourth trials, and fifth trial. Head or tail, whatever appears, that will be fulfill our requirement. So it is 1 head or tail. So 1. So answer is 3 into 1 by 2, 1 by 4, 1 by 8. Oh, sorry, another 2 is there into 2. So 3 by 16 is our answer. 3 by 16 is the answer. So next. An examination consists of 4 papers: A, B, C, D. One will pass if he pass in D and at least 2 from the rest. Rest means these 3 papers. So in order to pass the examination, one must pass at least any 2 of them and D. So if and moreover, one information is there, the probability that one student can pass the papers are half for A. For B, it is 1 by 3. For C, it is 1 by D. For C, 1 by 4. And for D, it is 2 by 3. So these are the respective probabilities of passing these 4 papers. So here it is clear that paper D is compulsory, and we have to pass at least 2 from the rest. That is 3, all 3 and D. So he will pass if pass in A, B, C and D, all papers. Or if pass any 2, A, B, C failed and D, then he will pass. In these 2 papers he passed and D. Similarly, A, B bar, C, D. A pass, B in C pass, B failed, and A bar, B, C, and D. 2 at a time. Okay. So this is the possibilities that a candidate, a student, can pass the examination. In this case, he passed all these cases. Probability of that, it is half into B means 1 by 3, into C means 1 by 4, into D means 2 by 3. For this case, A means 1 by 2, into B means 1 by 3, C bar means he failed it. So it is 1 minus 1 by 4. So it is 3 by 4. Into D means 2 by 3. In this case, A means half, B bar means 2 by 3, C means 1 by 4, and D means 2 by 3. And this is again A bar, failed in A, 1 minus half, that is half, into 1 by 3, into 1 by 4, into 2 by 3. That is 2 by 3 can be taken common from there, 2 by 3 into. This is they together 1 by 24 plus 4, 3, 24. In that case, 2 by 3 into it is 3 by 24. This is 2 by 3 into 2 by 24 plus. In that case, it is 1 by 24 multiplied by 2 by 3. So that it is equal to 2 by 3 into 24. 1, 4, 6, 7. That is, it is equal to 7 by 12, 36. Now, the options are not yet given. The options are number are 23 by 26, 36, 17 by 36, then 7 by 36, and 11 by 36. These are the options. And here we calculate that the total probability that a candidate may pass the examination is this, 7 by 36. So third option is 7 by 36. Oh, this is 36. So this is correct option. Next problem. One problem is given to A and B. Same problem is given to A and B. The probability that B alone can solve it is 0.38, and both of them can solve it individually is 0.23. Then the probability that B can solve it but A failed. B can solve it but A failed. Once again, I am repeating the problem. One problem is given to the two candidates A and B. Given that B alone can solve the problem is 0.38, and both can solve it individually is 0.23. Then what is the probability that B can solve but A failed? With the help of a Venn diagram, suppose this is B, this is A. B can solve the problem, means they together is 0.38. B can solve the problem is 0.38. This probability is 0.38. Both of them, A can solve, again B also can solve individually, is 0.23. That means this space is for common for A and B. So this is actually 0.23. This is the region, area where B can solve but A failed. And this white part is A solved but B failed. Now we have to find that what is the probability that B can solve but A failed. So we have to calculate probability of that part. They together, this and that, they together is probability of B, that is 0.23. 0.23 plus. B means B means that whole thing is 0.38 minus that part, common part is 0.23, that is 5, 1. 0.15 is this part where B can solve but A failed. So required probability is 0.15. Next. A pair of fair die is thrown. Probability getting a sum 9, that's P, and sum 10, it is Q. Then P plus Q is equal to how much? P plus Q. Options, first I am forgetting every time. The options are 5 by 36, 11 by 36, 13 by 36, and 7 by 36. Once again, I am repeating the problem. A pair of fair die is thrown together. P is the probability that when the sum of the faces is 9 and Q is the probability the sum is 10. Then we have to find the value of P plus Q. First of all, I calculate P, that is if the sum of the faces is 9. 9 from the two die can be obtained as follows: 9, 5 plus 4, 9, 4 plus 5, 9, and 3 plus 6 is equal to 9. No other alternative. So there are 4 cases. Sum of the faces is 9. That is, this is cases for P. So P, probability that sum of the faces 9 is equal to, it is m by n. M is equal to 4, 1, 2, 3, 4, and n, 2 dice are thrown together, so it is 6 square, that is 36. So 4 by 36, that is 1 by 9. Q, the sum is 10. It may be like that: 6 plus 4 is equal to 10, 5 plus 5 is equal to 10, then 4 plus 6 is equal to 10, and no other alternative. So for case Q, when sum is 10, possible cases are 3, 1, 2, 3. So Q is equal to m by n is equal to 3 by 36, 6 square, 1 by 12. So our answer is P plus Q is equal to 1 by 9 plus 1 by 12. It is equal to 36 is LCM, 4 plus 3 is equal to 7 by 36. This is correct option. Okay, today is up to this. Next day we will discuss a few more problems. Thank you.